Okay, thank you everyone for being here. Thanks for having me. My name's Avi Press. I'm the founder and CEO at Scarf. Just a little bit about me. I have an open source maintainer background. I'm also real deep in the Haskell community. I'm on the board of the Haskell Foundation. I used to work at Pandora as well. And about our company, we're much smaller than DoorDash, a 5-year-old startup, 15 people. And we do open source usage analytics, largely for sales and marketing intelligence. And we like to try to help companies that build and commercialize open source do that more effectively and help promote open source sustainability broadly with very strong privacy guarantees and very privacy conscious usage metrics that are still valuable to the businesses behind these open source projects. The product that we build helps people collect data on how their open source packages get used. And so we're ingesting a lot of data about things like package downloads, telemetry from software, and also cookieless pixel tracking for open source docs. And so we're collecting a lot of events around how different companies and organizations are reading about open source projects, how they then go on to download those open source projects and use them. We're processing about 1 billion open source downloads every month on our infrastructure. We're sitting in between end users and the artifacts that they are downloading. So you can kind of think of the main thing here as like almost like a bit.ly, like a link shortener, but you can Docker pull through it, you can pip install through it. It's working seamlessly with any package manager, any IDE, these kinds of things. And then that same infrastructure then also can sit in front of these cookieless tracking pixels and can also collect telemetry that you might be sending to it from your code. And meanwhile, our whole analytics pipeline is then analyzing that traffic, doing things like metadata enrichment to try to understand the companies behind it, then deleting the IP addresses and spitting out insights to the customer all in real time. And that real-time kind of requirement was what ultimately led us to look for technologies like Clickhouse. And so a little bit about kind of how we got to where we were. So back in 2019, this is just me coding this stuff, and we started with just a Postgres table for all of these events. And so we just had one package events table that we were putting all of these downloads into. We had most of these things in one table, and as we started working with bigger and bigger projects, that very quickly fell over. You can only push that so far. I think it was probably around like any time there was a project that would have like more than 10 million downloads a month, like the pages would just take forever to load, and it was a thing of throwing more processing power to our database, but then it was very clear that we needed more scalability. And so what we then went to next was still using Postgres, but doing pre-aggregations ahead of time. So we would have background jobs that would be computing things like a package, what we call an aggregation type. So this might be downloads by country, downloads by version, downloads by company. And we had these very specific aggregations that we were doing, and we would pre-compute them both in batches and like online as well. So we would have different roll-ups, so like a daily roll-up, a weekly roll-up, a monthly roll-up, yearly roll-up. There were some good things about this, like this could scale to pretty arbitrary size in the data volume that we would ingest, but it had a lot of problems, actually. Yeah, I'll get to this. So the tough thing with the pre-aggregations is what do you do when you want to show data that's not in those aggregations, right? These kinds of aggregations are lossy. So if we wanted to say, show something with multiple aggregations, like what if I want to do 2 of them? Well, bummer. You don't have a lot of options, and so you would then want to, okay, we'll make a new aggregation type, and we'll maybe add the ability to have a second grouping key. And it scales really well to the real-time aspects, but maintaining this is an absolute nightmare. And it's even worse if, God forbid, there's a bug and you got to go back and reprocess, and that's also very expensive to do when you're dealing with this amount of data. Like it's not humongous, but it was enough that like Postgres is not going to solve this. And so what we really found ourselves needing was more query flexibility. We didn't want it to be a huge pain every time we'd want to show a new graph that, oh shoot, we weren't already pre-aggregating by this. And then every time we added a new aggregation, how far back do we want to backfill the aggregations, right? And every time. And so This was clearly not going to work for very long, and then it got even worse because then we wanted to start doing, once we were doing some more marketing, and we wanted to do some like interesting reports and trends across all of the data. Well, with this aggregation thing, that's really, really hard, especially the unique counts. So we were using hyperlog logs in Postgres, which is really, really cool for what it does. So for those that don't know, hyperlog logs give you a really fast way to do things like unique counting on any kind of set that you want. It really solved the problem for us in the short run, but okay, we want to know how many unique users are downloading every package on Scarf. That's kind of tough to do. You can do things like, you can aggregate hyperlog logs in Postgres, but the loss compounds over and over, and you get way less accurate the more dimensions you have. And so that just really didn't scale. Pretty much every approach that we had in Postgres was essentially like hitting a wall somewhere, either with the performance for customers or for the maintainability of the system as it got more and more complex, as more customers came on, having more things that they needed. And then the cost started to really rise as we were backfilling constantly, just spending a lot of time on this. And it was really clear that we needed something that was more suited to the task. And so we went to Clickhouse, which was great. And we ended, you don't need to read this, but like we ended up getting to a point where all of the event data that we were storing and parsing basically makes it into our giant events table in Clickhouse. And so the general architecture of this, if I kind of just go back to this, is that anytime a download happens, so our gateway is globally distributed, so you're always going to hit a download from your closest gateway node, and we have basically all of those nodes will then basically queue up the raw events into Kafka queues, and then producers pull those off the Kafka queues, parse them, enrich them, get rid of PII, put it into Clickhouse. And that's the general workflow that we have for that. And having all of this in this big mega table, which we were all very new to Clickhouse when we started this. Like we didn't have any knowledge about it when we started, but it just seemed like the right technology for what we were trying to do, which is serve real-time and flexible dashboards to our users as quickly as possible and as flexibly as possible. And this really gave us a lot of what we need. We were able to give our customers very impressive real-time filtering capabilities. If I just go back to this really quick, so like being able to cut up your downloads in real time by just saying, I just want to see my open source downloads from the Fortune 500, or ones that happened in Canada and are in the banking sector, or banks in Canada who are using version 1.5 of our library and also looked at our pricing page. And that's just the kind of thing that you cannot do if you are pre-aggregating everything. You need the flexibility. You need this kind of very large table to have all of this stuff just real time available, query it, and serve it to the customer. And because in general, a lot of the people using Scarf, they don't even know what they're looking for necessarily, because a lot of them have never had the kinds of analytics for open source projects that we're able to give them. And so there was both this requirement of letting people poke around and explore, but then when they have really hard questions, we're still going to render that stuff really quick and just make it all available. Like the features that we wanted to give, we were able to do that with Clickhouse, and that was a huge victory for us. Just checking time, okay. The other really, kind of like interesting and specific problem to us is that we both let people, so we may sit in front of a download and collect that event, but we also might ingest telemetry from the customer as well if they're collecting it from wherever they might be getting it from. And one problem that we ran into with that is often they would send us the same events multiple times. And so we needed to have some notion of deduplication of these events. It quickly became very challenging. Like the data just eventually would become wrong if you were not deduping for the customer. Like basically let them have an event ID, so it would be idempotent when they re-import it. And what we found was that having this kind of global deduplication requirement was actually very hard, because you're basically going to slam that one data store anytime you need to check, like, have we seen this event before? Do we need to update this event, or what are we doing given this event that we've already seen? And as soon as we got onto Clickhouse, you kind of get that for free. It just, as long as you're indexing on that key, like, the deduplication is just going to happen when Clickhouse optimizes. And we didn't know that when we started, and so it was a very cool surprise. The engineers were amazed at this. It was a very cool thing to stumble on. Obviously the query speed, having the same kind of experience of we're just querying a database. We didn't really introduce like a whole map reduce situation. We just got right to using the same kind of database that we were already used to. Another really cool thing for us, not being familiar with Clickhouse when we started, was just how comprehensive all the functions that are available to you. So a lot of the things that we thought were going to be really heavy lifts in terms of coding up certain business logic, or doing maybe, I don't know, like the less precise but fast unique counting, or these kinds of things that really just solved a lot of our problems very quickly, and we were able to go from absolute no Clickhouse knowledge to operating it in production very quickly. And of course, we also saw that, the system tables were just really, really helpful for debugging. And this was all stuff of just 5 engineers learning this as we went, with a production system already out there and swapping it out in place. The workload that we have, I think, given the people here, it's probably pretty small. But for us, it feels big. We're writing about 25 gigs of this a day. We do about 50 million events that are getting written every day. I don't know what I can say, 60,000 writes a day, but really heavy on the batching that we do. I'm sure there's just astronomically high workloads, and this is not very big compared. But this is all happening on one shard and a replica. It's really small, but it really gets the job done for this is for billions of events a month that we are doing on our platform and serving analytics in real time. So the delay from someone doing a Docker pull through Scarf Gateway to landing in your dashboard is usually about 5 minutes. If we're under a heavy load, it might be longer, and it all kind of gracefully slows down, but it always, it's very durable, and it kind of just works. A few issues that we had to solve for as we were getting started. One, and this happens with pretty much every new tech that we pick, we're a Haskell shop, a hilarious choice, but it really works well for us. But there was no mature Clickhouse client for Haskell, and so we wrote one. We are going to open source it pretty soon, so stay tuned for that. There are other Clickhouse clients for Haskell, but none of them were very complete. None of them were really well maintained, and so this is what happens when you pick obscure programming languages, is that you got to write your own clients for a lot of stuff, just the way it goes. A lot of the startups might relate to this. You don't necessarily know all the requirements of what you're building when you set out to build it. Things change. A big customer comes in that has some new requirements. You're like, well, we have to figure out a way to do this. And so we found that when we had to do large aggregations that didn't fit into the index that we initially hit, you'd blow up memory really, really fast. And it was challenging to figure out kind of the right way to lay out our tables ahead of time, and it took a lot of learning, and every time we had to switch, that was quite painful. Also, small things, we didn't realize that we had a big nested OR things, and we had to switch that to in, and these kinds of small things that you learn. And then another piece was that this deduplication functionality that we were relying so heavily on was actually very confusing for us to figure out when we should just use final on queries or when we could just rely on Clickhouse to optimize. I would say this is still one of those things that is, there's edge cases that we are still kind of working through with some of this, but generally we're able to largely just rely on optimize and do finals pretty sparingly. A lot of problems that we still have not solved, so I'll talk about some of those. This one, I think, again, is more for startups that are really just getting going. if you need to change your indices because this is how all these, this is how the table is laid out in memory, this was a very challenging thing for us when we didn't really know all the answers to how we should design the tables. And I think part of this was largely just that we didn't really know what we were doing when we were designing all of this stuff, but it was really good to we pulled in a lot of outside help and we got past all of this stuff. Another thing is about the trade-off between pre-aggregating stuff while also keeping dynamic filtering. So the idea right now is that all of the dashboards that we serve and all of the preset ways that you can filter Scarf data works very fast. But sometimes we want to add features that involve querying across things that are not in the index. And then we're met with a couple of options that both have really significant drawbacks for us. So if we do a materialized view for that would lay things out properly for us, well, then we lose the deduplication because a duplicated event may hit our events table, and then it would get copied to the materialized view before the optimize is maybe run. And then we would be left with duplicate events in maybe one view. Another view might have different duplicates, and then the base table will deduplicate at some point in time. And then separately, if you're doing other kinds of other kinds of approaches to this, well, are you filtering before you aggregate? Are you aggregating before you filter? And the way to approach this, I think, is a little bit of an open problem for us. But if there's a world where materialized views have more robust refreshing capabilities, that would help us in this way. And then finally, again on this deduplication piece, the fact that replacing merge tree is tied to the disk ordering, it basically means that we're much more constrained with the ways that we can architect our data schema because we're relying on this deduplication so heavily. There was work being done on unique merge tree, which would solve this, but I think the pull requests that had this did not fully solve the replication components of it, so it wasn't able to be merged yet, but it sounds like there may be some things coming that may help us with this, so I'm looking forward to whatever that looks like. That is all I got, so thank you very much. If there's any questions, happy to take them. Maybe, maybe not. The original thing that I wrote for Scarf back in 2019 was actually a system package manager. And it would essentially install binaries inside of a wrapper layer that could collect analytics, but you could also take a payment for something. And so it's kind of riffing on this idea of wrapping other people's software, and you could type it from one hand on the command line, so I just really liked it. And we don't do that anymore, but the name kind of stuck around, so yeah.
For deduplication, did you evaluate using argmax or window functions instead of using final? Did you try that out by any chance?
I guess I'm not really sure since I wasn't the one doing a lot of this coding. I believe I heard something being talked about with respect to this, and I think we were not able to make it performant enough for some of the queries that we were doing, but I'm not actually sure. It may be possible that would help with this stuff, but I think the idea would be that we would have to do that on everything that we would do. So even, for instance, we have a Metabase instance that we use internally to just do basic business intelligence, and it would be really tricky if you had to run these just-in-time deduplication windows right at the end. It would basically make everything downstream pretty inconvenient. Yeah.
Hey, Avi. Thanks for all of that information. This is great. Curious if your team plans on testing with refreshable materialized views at some point for some of the latter piece that you were talking about. And then secondly, for the dynamic filtering that you were talking about, curious if you got a chance to test out projections at all, or if that was something that you had considered.
The projection stuff has been looked at. I don't know off the top of my head there was something about it that did not quite meet what we were needing, but I can definitely follow up with you about it. And yeah, we will definitely be playing with the refreshing merge trees for sure. Yeah.
Are you able to stream data from Hackage or Haskell infrastructure?
Sorry, one more time.
Are you able to stream data from Hackage?
Stream data from Hackage?
Yep.
Oh, yeah. Not yet, but we're actually, we're very likely going to be partnering with the Haskell Foundation in this way, so we can basically get the data out of Hackage and Stackage. But we can't really proxy requests to Haskell packages easily without like a lot of URLs being rewritten upstream, and so basically the main way to work with the Hackage ecosystem is to partner directly with like the infrastructure on them. So we actually already help track GHC up, but Hackage packages are coming.